So today we are going to discuss about uh, the subject environmental engineering, and for in that there is the most important subject and most of the student gets confused with this topic. So we will be learning the um impact of wind with pollutants. So this is so important topic, and for all government exams and all other in your semester exams also. So you can see that this topic is so confusing that people cannot remember it well. So I am going to teach you uh, in a better way so you can remember it for long time. So first of all we have to know that what is ELR. ELR means environmental lapse rate. So ELR is nothing but it's the air like rise of air with the height. It is called ELR, environmental lapse rate. And what is another one is ALR, that is adiabatic lapse rate. What is adiabatic lapse rate? Adiabatic lapse rate is, this is you have to understand well that when you release a hot air in the environment, so what is tends to, it tends to rise up, but it keeps rising until it gets settled when the temperature of this hot air got satisfied with the environmental surroundings air. Don't get confused with the environmental word. So it is the surroundings air. When the temperature of this hot air gets satisfied, so it stops rising. So that after that's the total rate with the height, that lapsing rate is called adiabatic lapse rate. So after adiabatic lapse rate, we will be knowing that there is three type of condition with this ELR and ALR. So if ELR is greater than ALR, okay, then this is super adiabatic condition, and when ELR less than ALR, then this is sub adiabatic condition. And when these two is equal, then that is the neutral condition actually. So that is the neutral condition. Okay. So you can see that from here these three type of condition is there. There is another more two conditions, that is inversion. Inversion is there, and subsidence inversion is there. So inversion is when this ELR when you see that ELR, what is happened, that when you tends to increase, like ELR happens like when the height is increasing, the temperature is decreasing, but for the inversion it's inverse, like it reverse. So it will be happening that when height is increasing, the temperature also increasing. That's the inversion. And subsidence inversion also the same, not the same like inversion, but it is like when the submerging of air due to the high pressure, when the surroundings air pressure is low, so that is the subsidence inversion. Okay, you just remember these three and inversion, that will be enough for your exam or all semester exam or government exam or what another competitive exam, whatever it is there. So it will be enough. So first we will be learning what is plume using these three condition, and I told the inversion. Okay, so inversion is there. So inversion, this is inversion and these three conditions. So up using these four conditions we will be learning the plume. What is plume? Plume is like the stresses of gaseous particles, like the which are pollutants are made of. So those are the those behavior or those trace or the path that is made by those gaseous pollutants particles. So that is we are talking the plume. So there is many type of plumes is there. The first type we are going to see, that is looping plume. Okay, so first looping plume. So in the looping plume, what is there? There is the condition is super adiabatic. So we know that when the condition is super adiabatic, the lapse rate ELR will be greater than ALR. So what will be the stress path of this plume? So let's draw that stress path of that plume. So trace path of the plume, just let's draw it. So this, let's take, this is the chimney. So this is, let's take, this is ground level. Okay, this is ground level, and this is the so this is the trace path of this looping plume. So we are telling this plume is looping plume. So what is the characteristic of this plume? That here ELR, that environmental lapse rate, will be greater than ALR. And the most important thing, this is so polluting that it will be touching the ground. So this is so dangerous for the surrounding people or the residential buildings or people surroundings there. So it will be, this plume will be touching the ground. Okay, because of this ELR greater than ALR. The condition it is will be having, that is super adiabatic. So this plume will be having super adiabatic condition. So we will be telling this just remember this diagram, that will be enough. And they will be asking the question about if the ELR is greater than ALR and that is touching the ground, pollutants trace path is touching the ground. So what will be the name of the plume? Okay, the second one, just see the second one. So second one is coning plume. Okay, coning plume. So now first let's draw it. Okay, then you will understand it better. So you just remember it through the picture. Okay, that will be the best option to remember. Otherwise you can understand through these concepts also, that ELR greater than or less than whatever it is. So Okay, this is ground level, this is the stress path of this plume. So what I am saying, we are saying that this is, let's suppose this is a chimney of some industrial place. So from there the stress plume is coming like a cone. Because of that we are telling it coning plume. So what is the characteristic of this plume? So characteristics is that ELR will be less than ALR. Okay, ELR will be less than ALR. So we know that for this condition, condition, what will be, we will be naming this condition. So that is subadiabatic condition. Subadiabatic for these things to happen, like if these things happens, like ALR is greater than ELR, so then we will be telling this is subadiabatic condition. Okay, when the subadiabatic condition happening and the cone like stress path is happening, so that will be we telling that coning plume. So next, see the next one, that is after we got the two condition of first is looping plume and then coning plume, then see the next one, that is the neutral plume. So neutral plume is so the third one, that is neutral plume. Okay, so neutral plume, we know that when ELR is equals to ALR, so that's the neutral condition we have. This is that plume is this. Okay, so when ELR is equal to ALR, then neutral condition okay, this is the neutral plume. When ELR equals to ALR, neutral condition happens. Now see the picture how it is coming. So this is the ground and this is the stack or chimney, what you can say. So because of ELR of ALR, this is just simple upward movement of air. There is no surrounding movement of the air, just simple upward rising of the air with the pollutants, and this is neutral plume. So when the ELR, that is environmental lapse rate, is equal to ALR, adiabatic lapse rate, then this condition happens. Okay, and this plume we call the neutral plume. And next, come to the next one. Let's see the next one, that is fanning plume. So fanning plume. Okay, so what is the main characteristic of this plume? This plume happens due to the extreme inversion. Because of the extreme inversion, this plume happen. So we have told that, I have told that what is inversion. So inversion is the negative ELR, the negative lapse rate. Okay, that is the ELR. So when the extreme inversion happens, extreme inversion, then this plume happen. So let's see the picture of this. So this is inversion, okay, and this is also inversion, this also. So because of the extreme inversion, the pollutants, the gaseous pollutants does not disperse. Like this, it disperses, but it does not disperse in the with the height. It disperses with the horizontal, like continuous dispersion respect to the horizontal, like that. Just you can say like just totally parallel, you can say, to the ground. Okay, so that's why we are calling this fanning plume. So you can see when a fan rotates, the winds actually comes like most of the wind comes forward. Okay, similar here also there, like only the dispersion of gaseous pollutions is only the forward with the horizontal distance. So this kind of condition or this kind of situation we call is fanning plume, and because of extreme inversion this happens, fanning plume. Okay, go to the next one. The next one is fumigation. Okay, so fumigation. Okay, so here not extreme but only the inversion upward, and just see, this is inversion like there. So happens. So this is inversion and super adiabatic condition. Okay, and these things happens when the stack height, and this height is generally less. So we will having super adiabatic condition here and inversion here. So because of these two condition combination, so we will be having the plume that is called fumigated plume or fumigation plume. Okay, so this is so dangerous for the people around there, and this is not preferable at all, because you can see the pollutants are coming to the ground, totally polluting it to the surrounding the ground level and surrounding area. So this is not recommended at all. So this is this plume is so dangerous for the people around. So this after that we can tell that this because of this super adiabatic condition and because of this inversion there, the total gaseous plumes comes to the ground level. Okay, so come to the next one. Next come to the next one, that is just the inverse of the last one I said, that is the this one is the lofting plume. So this is lofting, this is the lofting plume. Okay, so for that what it is there, just remember this is just the inverse of the last one I said. Okay, so what was happening in the last one it was happening, just draw a line here. So last was happening, inversion was there, but for this one inversion will be in this side. So in this side will be inversion will happen. Okay, so after that the last one what we said, that this in this side was super adiabatic was happening, but this time the super adiabatic will be happening in from here. Okay, this is the lofting plume. So lofting plume, this is the super adiabatic condition here, and to the ground level, like near to the ground level will inversion will happen. So and this kind of plume we generally see when the height of the stack or chimney is high. So height of the stack or chimney is high, this kind of plumes we see. That's why you can see when the any industrial place you will see the chimneys are too high of height. Because of that, because of we want this plume to happen, that's why we keep the stack chimney height so high. So this plume is so useful for the people because you can see the inversion is there, so there will be no gaseous pollutants, almost null. So because of that, the people will not have any effect, or will be having the much or less effect than the last one. And in the above you can see the because of superadiabatic condition, so the gaseous pollutants will rise. Okay, it will not come to the near to the ground, and this kind of plume we call the lofting plume. Okay. So you can see that because of the inversion near the ground and above the plume level, because of these two inversion, the plume gets trapped. That's why this plume is called the trapping plume, and this happens because of the inversion. Okay, inversion. And the most noticeable thing is, this is the most dangerous one, even dangerous than fumigated plume, because this because of this trapping of this plume cannot get dispersed, like dispersed through the atmosphere. Because of this trapping, the local place gets most affected. So this is the most dangerous plume. Okay, and this is happens because of this inversion.